All right, so this is my setup. I've got hot water coming in the red line. It comes up. Before it goes up there, it returns back to the boiler right there at that T. I don't know about y'all's water, but my water always flows to the point of least resistance. And so it flows through that T, and it also flows up through here at a slower pace because it runs up through a strainer, so I catch any sort of contaminants that are of decent size, and then it goes through that valve into a mixing valve, and this mixing valve mixes hot water with cold water, and whatever comes out of it you can adjust. I've got mine set at 130 degrees. Actually, it's 130. Yeah, we're at about 130 right now, and that goes into my floor. So the hot water comes into the mixing valve, gets mixed in with water coming out of the return from the floor. So it goes up into this air purger, manifold type thing with the automatic purger on top. That works great. Below that is my expansion tank, and I don't think I set any pressure on this system since it's an open system, but there is pressure built up because the floor is a closed loop in a sense that when that mixing valve is shut, this one here, when it's shut, it's basically a closed loop, and so it builds a little bit of pressure. Right now we're at like 5 psi. So, and then it goes into 4 zones, or 4 runs, I guess, that are all 200 to 225 feet apiece. They return back here, and I mean, it's just 1/2 inch PEX into a 1/2 inch to 3/4 inch PEX manifold, and then it goes to my circulator pump. The reason I have a circulator pump on my return side is because I used to have it hooked up to this pressurized boiler system, and for pressurized boiler system, or no, not because it's pressurized, just because it was hot water coming out of there. I didn't have the mixing valve yet, so I wanted my circulator pump to be on the return side, so it would always be working with cooler water, so it didn't shorten the lifespan of the pump. It's still cooler water, so I think it's quite a bit cooler than what's going into the floor. I would assume it's returning at about 80 degrees. I don't know. I need to get a gauge set up in my return setup. Anyway, so it goes through, and it goes through a regular T. Again, it follows the path of least resistance. So it's going to go into my mixing valve almost always, because when it comes through here, it comes through a check valve, which it's a one-way check valve. It's meant to flow this way. There's 2 springs and 2 flappers on that check valve, and it sort of holds pressure to that T, so it's always flowing through there. And then when the mixing valve closes more and it wants more hot water, it's going to flow more that way. So then it flows back through and out through here, back to the boiler. This line is always very hot, and this line is always very hot. So I'm really actually using a lot less hot water efficiently than I could be. I mean, I've got a lot more demand, or I've got a lot more supply than I have demand. I could hook up a external heat exchanger, which I may end up doing. I've got this one here. It's pretty large. It's got a big old squirrel cage fan in it, and I'm planning on hooking that up if it gets real cold this winter to act as a backup, because right now I'm pumping 130 degrees into the floor. I think I could probably pump a little bit more and be okay. My lines are in a 32 by 40 slab, and they are spaced about 18 inches apart. I'm heating a 48 by 40 building with 15 foot tall ceilings. Everything is R19 batt insulation. 2 big doors. I got a 14 by 14 insulated door and a 9x7 insulated door, and then a insulated walk-through door. That's it. So yeah, that's my setup. It heats it in here pretty decent. I'd say it's probably 65, somewhere around there, 65, 70. Actually, this thing will tell us. Right now I've got this set up to a thermostat, which it doesn't really do anything for my system, but yeah, it's 65 in here. And outside it's about 22 right now, so not too bad of a setup. I struggled with many different options over the last couple years, or last 2 seasons anyway, and this is what I've come down to. I've got an outdoor wood boiler. It's only 120 gallon water capacity. It feeds a heat exchanger in my house, and it feeds this line out here. I built my own supply lines. This one's 100 foot long. The other one's like 70 foot long or 80 foot long, and it feeds both of those just fine. I've got Grundfos 2699 pumps on the boiler, and I've got this one in here on my circulator just for my infloor, and I plan to change that out with like a Takeo 0015, so I have a speed option to where I can run it faster and actually maybe get a better return line, like a hotter return line, so I can get a little bit more heat in the building. But so far this is working great. I'm thrilled with it. It's a jumbled up mess, but it's working well. I've had a lot of troubleshooting to get to this point. I started out with a instant propane water heater. It worked okay, but it ate through about 100 gallons of propane a week. That was unaffordable. I tried a electric water heater. My lines are way too long for an electric water heater. If I had like 100-foot lines and a circulator pump that ran off of a timed cycle switch, I could maybe have made one of those work. But I can't, or I couldn't get a time cycle switch in time when I had that system running. So then I just went to this indoor Jensen boiler, and it worked great. But it ate a full cord of wood every week, and the firebox only would last for 4 hours before it was completely out, and I'd have to be out here every single night feeding it, and I got real tired of that, so I bought an outdoor boiler, and I now get anywhere from 8 to 12 hour burn times depending on what type of wood I throw in there. I'm able to sleep through the night now, and I'm able to go out and do things and not worry about getting home at a decent time to put wood in the fire. Anyway, that's my setup, and that's how it all works for now. If you have any questions, let me know.